Hi, this is Javin Kharor, a production chemical by profession, going to continue our today's topic, steam distillation. Now, steam distillation is a separation process that consists in distilling water together with other volatile and non-volatile component. The steam from the boiling water carry the vapor of the volatile to a condenser. Both are cooled and returned to liquid or solid state, while the non-volatile residue remain behind in the boiling container. If the volatile are liquid, not miscible with water, they will spontaneously from a distinct phase after the condensation allowed them to separate decantation or with separatory funnel. In that case, Clevenger apparatus may be used to return and condense water to the boiling flask. While the distillation is in progress, alternative, the condensed mixture can be proceed with fractional distillation or some other separation technique. Now, steam distillation can be used when boiling point of the substance to be extracted is higher than that of water and the starting material cannot be heated to the temperature because of decomposition or other unwanted reaction. It may also be useful when the amount of the desired substance is small compared to that non-volatile residue. It is often used to separate volatile essential oil from plant material. For example, to extract limonene boiling point 176 degrees centigrade from orange peels. Now, steam distillation once was a popular laboratory method for purification of organic compound, but it has been replaced in many such uses the vacuum distillation and supercritical fluid extraction. It is, however, much simpler and economical than those alternatives and remain important in certain industrial sectors. In the simplest form, the water distillation or hydro distillation, the water is mixed with starting material in the boiling container. In direct steam distillation, the starting material is suspended above the water in the boiling flask supported by a metal mesh or perforated spring. In dry steam distillation, the steam from a boiler is forced to flow through the starting material in separate container. The latter variant allows the steam to be heated above the boiling point of water, thus becoming superheated steam or more efficient extractions. Now, principles of steam distillation. Every substance has some vapor pressure even below its boiling point. So in theory, it could be distilled at any temperature by collecting and condensing its vapor. However, ordinary distillation below the boiling point is not practiced because a layer the vapor rich air will be formed over the liquid and evaporation will stop as soon the partial pressure of the vapor in that layer reach the vapor pressure. The vapor would then flow the condenser only by diffusion, which is an extremely slow process. The simple distillation generally done by boiling the starting material because once its vapor pressure exceeds the atmospheric pressure, then still vapor rich layer of the air will be disrupted and there will be significant and steady flow the vapor from the boiling flask to the condenser. In the steam distillation, that positive flow is provided steam from boiling water rather than by boiling the substance interest and the steam carry it vapor the latter. The substance of the interest does not needed to miscible water soluble in it. It suffix that it has significant vapor pressure at the steam temperature. If the water from azeotrope with the substance of interest, the boiling point of the mixture may be lower than the boiling point of water. For example, bromobenzene boil at 150 degrees centigrade, the normal atmospheric pressure, but a mixture with water boil 95 degrees centigrade. However, the formation of azeotrope is not necessary for the steam distillation to work. Now, principle behind steam distillation. When a mixture of two immiscible liquid, example water and organic, is heated and agitated, the surface of each liquid exerts its one vapor pressure as through the order component of the mixture was absent. Thus the vapor pressure of the system increases as a function of temperature beyond what is would be only one of the component was present. When the sum of the vapor pressure exceed atmospheric pressure, boiling begin. Because of temperature, the boiling is reduced. Damage to heat sensitive compound is minimized. Now, applications. Steam distillation is often employed in isolation the essential oil for use in perfume. For example, in this method, steam is passed through plant material contain the desired oil. The camphor oil and orange oil are obtained by this method as an industrial scale. Steam distillation is also sometimes used in chemical laboratory as one of the many substance separation methods. The steam distillation also is an important means the separating fatty acid from the mixture and for treating crude products such as tall oil, the extract and separate fatty acid and other commercial valuable organic compounds. On a lab scale, steam distillation are carried out using steam generated outside the system, the pipe through meta center, biomass or steam generated in situ using a Cleverger type apparatus. Now, steam distillation is a separation process used to purify or isolate temperature sensitive material such as natural aromatic compound. Steam or water is added to the distillation apparatus, lowering the boiling point of the compound. The goal is to heat and separate component at temperature below their decomposition point. Now, what is objective of steam distillation? The advantage the steam distillation over simple distillation is that the lower boiling point reduces decomposition of temperature sensitive compound. Steam distillation is useful for the purification of organic compound, although vacuum distillation is more common when organic are distilled. The vapor is condensed because water and organic tend to be immiscible. The resulting liquid generally consists of two-phase water and organic distilled. Decantation or pasteurization may be used to separate the two layers to obtain purified organic material. Now, uses of steam distillation. Steam distillation is the preferred method used to isolate essential oil. It is also used the steam stripping in petroleum refinery and the separate commercially important organic compounds such as fatty acid. Now, the extraction procedure. In the extraction process, the steam passes through the organic matter that contain the compound for separation. The steam condenses and form a mixture, steam and matter. The mixture gets heated further by passing the more steam, which continue to pass through the matter, evaporating the mixture. Due to reduced vapor pressure, the required organic compound evaporate as part of mixture. Moreover, its extraction take place from the organic matter. Separation procedure. The evaporated mixture, the steam and organic compound passes through a container that has cold water entering inside the one-off end after passing evaporated mixture through the container. It consists of cold water. The mixture passes through hot water from the another end. This resulted in condensation of the mixture. The collection of the mixture takes place. It settles down the separation. When the settling process occurs, the extracted organic compound come to the top. Their separation takes place by filtering out the water from below. Now, advantage the steam distillation. The advantage the steam distillation are the method that generate organic solvent free product. There is no need to subsequent separation step. The process large capacity for processing at the industrial scale. The equipment is inexpensive. The require less fuel for the steam boiler for extraction of oil. The advantage the steam distillation over simple distillation is that the lower boiling point reduces decomposition temperature, sensitive compound. Steam distillation is useful for purification organic compound, although vacuum distillation is more common. When organic are distilled, the vapor is condensed. In the steam distillation, the liquid boil when the sum of the vapor pressure due to organic liquid and due to water become equal the atmospheric pressure. In steam distillation, a mixture of organic compound and water boil a temperature when the sum of the vapor pressure of organic compound and water become equal the atmospheric pressure. The vapor pressure of water at its boiling point is higher and organic compound will vaporize at a temperature which is below its normal boiling point. Okay guys, this is up to steam distillation. I hope you gain sufficient knowledge of the steam distillation. Next topic we cover another subject of chemical engineering. Still then goodbye and wishes you a very happy weekend.